the actual idea of statistics then. So what is the subject matter? So we start off with a datum. That's a singular, by the way. Datum, singular, data, plural. It describes a single quantity, some object, phenomenon, whatever it is we're investigating. So in statistics, the data we represent with random variables. What is a random variable? A random variable is basically a function. And the value of it will be a real number, and that real number is determined by the probability of it happening. Now, random variables can be either numeric or categorical. Random variables will be continuous if the range is an infinite set of real numbers. So it's an interval. Whereas it'll be discrete if the range is countable. Okay. So it consists of individual values rather than a spread of values. So what is stats then? We're looking for techniques for descriptive statistics. So that's one of the things we do. How do we describe the stats? So the collection, the presentation, and the summary of all the data. So that's descriptive statistics. Then from there, we get the more interesting part, the inferential statistics. That's where we go and use that data to infer things, try and predict things and things like that. So let's look at descriptive stats. Right? So summaries about the data. So it could be a visual summary, simply with a graph, a table, something like that. Or it might be quantitative, where we use numbers. And we've seen that in univariate data, so one variable, we've seen measures of central tendency, mean, median and mode, and measures of spread, variance, standard deviation, range, interquartile range, all those sorts of things. In bivariate data, so that's where you're comparing one piece of data to another, then you have this thing called correlation, line of best fit. You've seen that a lot in science, I guess. So the visual summaries, frequency tables, probably the first type of visual summary of data that you saw. Now you can do frequency tables for both numerical and categorical data. Okay, so here's an example. Class of 20 students surveyed, how many pets do they own? And there's the answers. So we put it into our table. We used a tally. It was one of the first ways of recording it. So if I wanted to record this data in a tally, so that's a tally way of doing it, and then we can read off our tally and we get the frequencies. Okay, there's this thing called a contingency table. Now, a two-way table, another way of calling it, that's where we can do something like this, conditional probability problems. These are great for that. So when we break it down, the data into two types of categories. So it might be eye colour, so black, brown, blue, green, grey, but we could also split the people up based on gender. Right? So the different ways we could split up the people. So determine whether being male and having green eyes are independent. This is the sort of question we saw with conditional probability. Are these independent events? And a reminder, one of the ways of telling if they're independent is if the probability of A given B happens is the same as the probability of A. Then they would be independent because the fact that B happened was irrelevant. You still got the same probability for both. So let's work those out. Well, probability of male, so we'd look at it overall. Male, there's 82 out of 167. So, about 0.49. Male, given that they have green eyes. So now we just look down the green eye column. As far as we're concerned, that's all the data. So probability of male in that situation is 20 out of 35, which is 0.57. That's not the same as probability of male. So that would suggest to us that being male and having green eyes are not actually independent of each other. There is actually some connection maybe between being male and having green eyes. Interesting. Some of the common types of graphs and charts you would have seen. Line graphs, there's our pet one. Column graph. Pie graphs, or sector graphs sometimes they're called. Bar charts, which is simply a column graph turned on its side. Dot plots, we saw those before as well. You might not have seen this one though, what's called a Pareto chart. Used in economics a lot actually, Pareto charts. And it's good for when you're analysing stuff and you want to find frequencies of defects and how those defects impact all up. Here we go. Let's do this. It's got two graphs drawn together. Basically, you have a frequency histogram, but you arrange it in descending order. But then you have a cumulative frequency polygon. So they're both on the same graph. Here's our example. We're manufacturing shirts, and we've got some defects in it. So 23 shirts had a defect in the button, 16 in the pocket, 10 in the collar, 7 in the cuff, 3 in the sleeve. And you see the table has been organised so that it's decreasing frequency. That is what the Pareto chart looks like. So the cumulative frequency polygon is the blue line. Okay. And the frequency histogram is the orange columns, but they're done in decreasing, you'll see. Now on the left hand side we usually put the frequency scale, and on the right hand side that's where we put the cumulative frequency scale. So looking at that, if we wanted to work out, we want to fix up these shirts. Now we can't fix everything up. What should we focus on in production? And I say, well look, if you just looked at buttons and pockets, just focused on those two, then this would suggest we'd remove 66% of the defects. So this is why the cumulative frequency goes down in value, so you get the biggest defect first and you can work across, and then your polygon's going up. And you go, well, what's an acceptable level? Okay, if I get 66%, yeah, okay. I can do that by just focusing on these two things. If I wanted to increase that, then I'd say, well, now maybe if I focus on the collar, I can get it down to 90, well, what is it, 90, 85, something anyway. But that's the idea of a Pareto chart. They were visual ones. Quantitative summaries. Central tendency. Mode is the one that happens the most often, we know that. So in our example of pets before, the mode was one pet. Most people had one pet. Now, the mode might not be unique, and that's why it's not necessarily a great measure of central tendency, because data can have more than one mode. If you've got two things that happen the most, you're going to have two modes. So you could have bimodal. You could even have trimodal if 3 scores were the same. After that, we tend to just say, oh, it's multimodal if it's got more than 3. Median's probably a better one, because median, of course, measures exactly where the centre of the data is. Now, this is where we've got to be careful, though. Remember, when we have odd number of scores, then that's good. The middle score, range them in order, then the middle score will be the median. Nice and easy when you got odds. But when you got evens, you have to average the two middle ones, because there's not a number directly in the middle there. You split in the two sets of data and average the two middle ones. So the example we did of the pets, we would end up finding the average of the 10th and the 11th score, and that's 1.5. Okay. Well, data is what data is. Obviously you can't have 1.5 pets unless your dog's had an unfortunate accident or something like that. But statistically we say, okay, it's 1.5. Okay. The spread of the data, so range, difference between maximum and minimum. And probably not a great one, but only numeric data will have a range, of course, because if you're doing categorical, how do you subtract blue from red? I mean, you can't do something like that. Our example, 4 pets is the range. There's 15A. Quick recap on stats.